Sorry, the tech's acting a little slow here. It's kind of cold outside, and the electronics don't like it as much. Reporting to you for our second little lecture here. It's the first kind of mini little extra lecture on the extended linearity principle. I'm hoping that this can clear up a little bit of confusion about why we possibly would need this. Okay. So for the extended linearity principle here that we're going to be going over, we are going to try to piece together, prove each of those little claims that we had, and sort of how that helps us put everything together. So we've got our general second order constant coefficient, non-homogeneous differential equation in red, and we've got the homogeneous version that's associated with it in green, as per usual. And what we're going to be doing here, I wrote the boxes just so I didn't have to keep writing giant equations here. We suppose that x sub p solves the big general equation, and x sub h solves its associated homogeneous form. Then we claim their sum solves the big non-homogeneous format. So what should we do with this? Well, let's just write down the facts. If x sub p solves the first equation, I should be able to plug x sub p in, and any equality or inequality that exists should hold. Same goes for x sub h with the associated homogeneous problem. I should be able to plug it in for everywhere I saw the variable, and any equality, i.e. equals 0, should still hold. We're making a claim about their sum, so we might as well go ahead and add them together. We have x sub p plus x sub h double prime. We should be able to recognize this because the derivative of a sum is the sum of the derivatives and vice versa. Okay? And so we're just going to group everything like that according to derivatives. So we have p times x sub p plus x sub h prime plus q times x sub p minus r plus x sub h. And all that should equal whatever g plus 0 is. That's g of t. All right. Now what we should notice now is we've got something double prime plus p times something prime plus q times something equals g. That's exactly the fact that it should satisfy the first equation, the general form. So voila, we've proved what we needed to prove, right? I'm not wearing gloves right now. It's cold. So for the second fact here, we're going to highlight everything the same here, but we're going to suppose that we have an x sub p and an x sub q, which are both solutions to the full problem, non-homogeneous problem, and that their difference, therefore, solves the homogeneous problem. Right? This is making a different sort of claim here, that if you get two solutions that happen to be different from one another, x sub p and x sub q, then what is missing from one or the other is actually just like sort of the core of the physics without the forcing. It solves the homogeneous problem, okay? So we write down our facts by plugging everything into the problem as needed. And we should point out now that the coefficient p is not the same p as the subscript, and the coefficient q is not the same as the subscript q. We're making a statement about their difference, so we're going to take the difference and we're going to continue to group it according to derivative. And what we're going to notice is a very similar thing. We've got the something double prime plus p times that something prime plus q times that something, and that's going to equal g minus g, which is 0. I left out my prime. We're going to add it in just a second when I remember. But let's look at that. See, xp minus xq, that's our something there. And so that's really powerful because this right here is a statement saying that that something solves the homogeneous problem. Okay, so we're done proving those two things. And I guess the last part is, how do we put that together to say this is how you construct the general form of the non-homogeneous problem? Because I think it's a little bit of a leap, and it can be a little confusing because it's more of like a logic puzzle than construction based, right? So I ask you, what's the most general way to write down the solution to the green equation? Well, if you remember from our recipe in the last full-length lecture, it's going to be some number times some function plus some number times another function. Now, that may feel like we're not really explaining a whole lot there, but think about it. It's either the function is going to be e to the lambda t and e to the other lambda t. That was well spoken. Or e to the lambda t, e to the lambda t. Or e to the alpha t cosine beta t and e to the alpha t sine beta t. So all those guys are covered in just that little general form right there. Okay, so we have the most general way to solve a homogeneous. Now, I want you to pretend that somebody says, hey, this solution to the full equation is the only solution. It contains everything. Everybody else is a special case. And so you might be thinking, well, okay, but by our previous assertions here, okay, anything missing from a full solution solves the homogeneous problem. Okay, so if I take your full solution and I subtract off the solution to the homogeneous problem, I should actually have just some particular solution to the full problem. Maybe it's not everything, but it's a particular one, right? That's what that first bit was saying. Okay, and I think that's really strong. You know, because like, what could possibly be missing from X sub P, right? You know, just only from that spot, like, what could we possibly have that is not there? Well, the only thing that's missing there from X sub P is the homogeneousness, so that core physics problem there that's missing from the full solution. So if we take X sub M and we just set it equal to X sub P plus X sub H, that's saying, okay, great, this is how you can describe the full thing. But we're still left with, but who is that X sub P? Does it matter how I bother to find that particular solution? And the answer is no. Because in both of the previous parts there, it didn't matter what X sub P and X sub Q were. Did you guys hear my baby screaming? Just going nuts. It was just general. So what's missing is just any sort of particular solution. It doesn't matter which one you use. And so we've been using the method of undetermined coefficients to find ours. And that's what you can use to find yours too, right? See, because you have any two general ones, their difference is homogeneous. So if you claim to have the master, just subtract off the homogeneous, and that's the particular, or just take any particular solution and add it to the homogeneous, and you have the master equation, that general solution. All right. Thank you, guys. I'm going to be hopefully changing location soon. We'll see. Bye-bye. Where's the stop button? Where is it?